So let's begin our starting of the session, the beginning of the universe, from nothingness to everything. We all have questions, no? Like how this universe is created from nothing. It's just okay. So before starting the session, I want to know your answer. Like, what do you think? Like, why did our universe actually exist? Do you all have any answer? Anyone who will like to share me something? Yes, please, so that I may know that how much you all know. See, I know you all know about the facts of the universe and all. I mean something, right? But what I want to have is like an interaction between us because you can find the information anywhere, like Google, Chat GPT, anything. But you will not find a person no, to speak about. So for that reason, because of unique chemical reaction between two nuclei. Okay, yeah, this may be. There are actually many reasons, and we are not settled to any actual reason, like why the universe has begun and why we are here. There are many existential questions. Like you may question yourself, no? Like why are you all even existing? No? And like us, there may be many. Okay, Big Bang, quantum fluctuations. Yes, yes. So, yes, our today's topic will be going to be about Big Bang. So, why did I even choose Big Bang? Because Big Bang is the most relatable theory till now. Like scientists have given many, many theories. There are actually many theories. But why Big Bang? Let's see why Big Bang. So, what Big Bang theory says is, see, our universe is about like 13.8 billion years ago. It happened, Big Bang. Now, before starting this theory, I want to say you all that it's a misconception that Big Bang is a explosion. It's not an explosion in space because it was an expansion in space. So we might have a question, no? Like what is even meaning of explosion and expansion, how they are two different. See, explosion is something which is like something which have been exploded. Now for that explosion there must be needed something, right? Something like any kind of explosion, there must be two particles at least. So before starting of the universe, how there can be a kind of particles? Like some says that two stars were collided and the Big Bang was. It's not true. It's just for like, okay, we can understand that it was collided. But what actually says is that it's an expansion. Why an expansion? Because in our universe, there is a space-time mesh-like structure. Now, you may be thinking, what is mesh-like structure? It is actually just imagine like a cloth which is like which is spreaded all over our universe. And in that space-time mesh-like structure, you know what happened was it at one point it became extremely hot and dense. Like the space mass was just spread over. And because of that, the Big Bang started. And in that Big Bang, all this energy, space, time, this all compressed together. and our Big Bang started. Okay, like uh, I want you all to just open your mics so that we can talk. It will be much like you all are listening and I'm talking. It doesn't feel much right. Yeah. So if you all will speak up like whatever I said till now, you can ask any question so that I will know that yes, you are at least understanding. Okay.
Ma'am,
Yes.
I have some question.
Okay. Ask.
Ma'am, what is black hole, ma'am?
Okay. Black hole. So
Yeah.
uh, I want to say like okay, according to this topic, black hole is something different, but I would like to say something about this. So black hole is like when like stars are there, no? So what happened is like in our space-time mesh-like structure, when a star dies or there is a big collision, the space-time just tears up. And because of that, a structure comes like black hole. Black hole is something which just pulls all the matters inside. You know, black hole is a very different topic, and scientists are still thinking about like why things are going like that. We do have the picture of black hole. Yeah, it was very hard to click that photo of that black hole. But you know, black hole is a topic which is something to be noted because we can relate black hole to Big Bang, no? Right? Because Big Bang was something from which particles came out, and black hole is something which is pulling the particles inside. So don't you think that black hole and Big Bang is a related question? So this might be. Now let's uh, begin with our topic. So yeah, this was so in that Big Bang, what happened is like before, like after the Big Bang started. So what happened is there was an extremely hot space-like structure. Okay, so on that time, particles didn't came out directly. It was like everything was so hot that everything just spread out. Okay, so in that spreading things, slowly, like it was so hot that afterwards, when it started to cool down, so there were electrons, protons, neutrons, like say, there is Planck era. Planck era is the earliest moment we can talk about before that our physics breaks down. It's a very interesting thing, no? Like does we have many laws of our physics. So did laws of physics existed before Big Bang, or it came after Big Bang? It's a question. So Planck era was like something like 10 to the power minus 43 second. You just can't imagine like so small period it was. So in that time, you know what happened? Our fundamental forces like gravity, electromagnetism, strong nuclear force, and weak nuclear force, this all were unified. Unified in the sense this physics law came in existence. Because okay, one interesting question is like, did time existed before Big Bang or time came to existence after Big Bang? Tell me the answer. I want to know what do you all think about this. You can type it so that I can know what do you think about did time existed before Big Bang or it came to existence after Big Bang? What do you all think? Type it down. It's like whatever. It's not about the answer is right or wrong. I just want to know that what you all are thinking. Okay. Uh, It will be good if you all will type it out. But okay, fine. No worries. I hope you all are listening because in this kind of meeting, it feels like okay, I think there was time. Yeah. This is an important question. Like, yeah, there may like time may have existed, like because we can think, no, like time was neither born and it will never die. Time was always there and it will always be. We can think like this. It's a big question because, yeah, we can say that if the Big Bang started because of the space time mesh like structure, so space time means it's also a kind of time. So it means time must have existed. If anyone have any kind of doubt, you can ask so that we will clear out line by line. Okay? Okay, good. We need to have this kind of interaction. I think there was time. Okay, Vivek, fine. Now, space-time was fluctuating wildly due to quantum effects. Okay, so what are quantum effects? So quantum effects are, we have two kind of physics. That is classical physics and quantum physics. Classical physics deals with like normal day structures and all, like forces and all. But when it comes to atoms, like smaller units like protons, neutrons, electrons, that classical physics theorems breaks down. So for that reason, quantum physics came into existence. Okay. So fluctuate like space time was fluctuating widely. You can think, no, like there was a expansion in the space time. So this might be fluctuating because yes. So this is the reason. So this was the smallest area. Before that, we can't see what happened. This is like a timeline. Okay, the Planck era, in which, and then after that, this inflation era came. So what is inflation era? So after the Big Bang, the universe expanded very rapidly. Like there is one question, like uh, what I have learned is like people says that the universe expanded faster than speed of light. But I doubt in this thing, like how something can be faster than light. Like scientist says that nothing can be faster than light. Then how the universe expanded faster than the speed of light? Can you all tell me about this something so that I may know? Like, do you think that how universe expanded faster than light? It's a very different question. Like, yes, how universe expanded? Because like it is written that because anything moved faster than light, but because space-time itself stretched extremely rapidly. It means that, see, when the space-time was stretched, so it was stretched so rapidly that it moved faster than light. Okay, so this is the reason why we don't know that what happened in that era. We do have big telescopes like James Webb Telescope, which have clicked photo of early days, like um 13. I mean that many pictures, no, which have shown our past. So why was not James Webb Telescope able to click pictures of that period when our universe was born? It is because the universe expanded faster than the speed of light, right? And if something is faster than speed of light, James Webb Telescope, what does it do? It captures the light of the previous past times. Like we see the stars. Why we are able to see the stars? Many stars have already died, but we are able to see because its light is still coming to our Earth, and that is why we are able to see. So, if universe was expanded faster than light, that is why we don't have a certain proof how did it was able to came in existence. Okay, now this moved out the universe and explains why it looks so uniform today. Now see, it was so rapid that even because of the fluctuation in the space time, but it was so fast that it looks so uniform. Okay, because of that rapidity, the expansion of universe was uniform today, and this was the inflation era. Now after the inflation era, formation of basic particles. Now I want to say, like, before formation of basic particles, there were dark era. Dark era means after the Big Bang, the our universe was extremely hot at that time, and because of that hotness, there was no existence of any particles and all. Like gases were moving around, but there were no electrons, atoms, or anything. That was dark age. Dark age means no other particles, nothing. There was no galaxies, planets. It was not existing. And what happened was, in that dark era, uh, slowly when the universe began to cool down. So when it was hot, how there will be formation of anything? No, they were all separated from one another. So what happened after many years? Slowly the Big Bang started to cool down, and and because of that coolness, slowly, see, as the universe cooled, quarks, that is building blocks of protons and neutrons and electrons, formed. So this is the thing. When the universe started to cool down, then